welcome to GCSE Maths Help. Today we're going to be looking at estimating exam paper questions. This video is a follow-on from my estimating key points video, which I will link in the bio below. If you haven't watched that video, you might find it useful before looking at exam questions. For everyone else, let's get started. So this first question says, the length of a roll of ribbon is 30 metres, correct to the nearest half metre. A piece of length, 5.8 metres, correct to the nearest 10 centimetres, is cut from the roll. Work out the maximum possible length of ribbon left on the roll. So let's start with the roll of ribbon and work out the smallest and the largest numbers that could be rounded to 30 metres. So we'll have 30 metres in the middle. So the smallest number that could be rounded up to 30 metres to the nearest half metre would be 29.75 metres, because 29.74 metres would be rounded down to 29.5 metres to the nearest half metre. So at the top, the biggest number that could be rounded to 30 metres to the nearest half metre is 30.24 metres, because 30.25 metres would be rounded up to the nearest half metre. So let's have a think about the piece of length that's been cut. So we've got 5.8 metres to the nearest 10 centimetres. So the smallest number that could be rounded to 5.8 metres is 5.75 metres, because 5.74 metres would be rounded down to 5.7 metres. At the other end, the biggest number that could be rounded down to 5.8 metres is 5.84 metres, because 5.85 metres would be rounded up to 5.9 metres. So in order to work out the maximum possible length of ribbon left on the roll, we need to start with the maximum possible length and take away the smallest possible length of ribbon from the roll, which will leave us with 24.49 metres of ribbon, which is the maximum possible length of ribbon left on the roll. So our next question says, use your calculator to work out 19.42 squared minus the cube root of 1006 divided by 4.95. Write down your full calculator display. So be careful how you type this into your calculator here, because our basic maths knowledge tells us that in a long line of things happening like this one, we need to do the multiplication and the division first before we do the addition and subtraction. So we need to divide the cube root of 1006 by 4.95 first before taking it away from 19.42 squared. So if you pop it all into your calculator, the full calculator display is 375.1121656. So part B says, use approximations to check that your answer to part A is sensible. You must show your working. So I'm going to round 19.42 squared to 20 squared. And I'm going to round the cube root of 1006 to the cube root of 1000. And then I'm going to round 4.95 to 5. So that gives us 400 minus 10 divided by 5, which equals 398. So our estimate is a reasonable estimate of the first calculation. So our last question says, a box is a cuboid with dimensions 27 centimetres by 15 centimetres by 20 centimetres. These dimensions are to the nearest centimetre. DVD cases are cuboids with dimensions 1.5 centimetres by 14.3 centimetres by 19.2 centimetres. These dimensions are to the nearest millimetre. Show that 17 DVD cases stacked as shown will definitely fit in the box. So because all of these values have been rounded to the nearest centimetre or the nearest millimetre, we need to work out what the smallest and the largest possible values could be for all of them. So for the box, the 20 centimetre length has been rounded to the nearest centimetre, so the smallest value it could be is 19.5 centimetres. The largest value it could be is 20.4 centimetres. The 27 centimetre length has been rounded to the nearest centimetre, so the smallest value it could be is 26.5 centimetres. The largest value it could be is 27.4 centimetres. And the 15 centimetre length has been rounded to the nearest centimetre, so the smallest length it could be is 14.5 centimetres. The largest length it could be is 15.4 centimetres. So for the DVD box, 14.3 centimetres has been rounded to the nearest millimetre, so the smallest it could be is 14.25 centimetres. The largest it could be is 14.34 centimetres. The 1.5 centimetre length has been rounded to the nearest millimetre, so the smallest it could be is 1.45 centimetres. The largest it could be is 1.54 centimetres. And the 19.2 centimetre length has been rounded to the nearest millimetre, so the smallest it could be is 19.15 centimetres. The largest it could be is 19.24 centimetres. So in order to make sure that the 17 DVD cases fit into the box, we need to take the largest possible amount of the DVD dimensions and make sure they're still smaller than the smallest possible dimensions of the box. So the largest possible height of the DVD box is 19.24 centimetres, which needs to be smaller than the smallest possible height of the box, which is 19.5 centimetres. We need to make sure that the largest possible width of the DVD box at 14.34 centimetres is still smaller than the smallest possible width of the box, which is 14.5 centimetres. And then lastly, we need to make sure that the 17 DVD cases at the largest possible length they could be, 1.54 centimetres, is still smaller than the smallest possible length that the box could be, 26.5 centimetres. So 17 times 1.54 centimetres is 26.18 centimetres. So all of our inequalities are true, so that means that the 17 DVD cases will definitely fit in the box. I really hope you found this video helpful. If you would like to have a little recap on the key points on this topic, click the link in the bio below. Don't forget to subscribe to GCSE Maths Help with the subscribe button below, or you can check out my Instagram page at GCSE Maths Help for more videos and tips. Thanks for watching.